Welcome to Notes 5-4A. We're focusing on factoring polynomials, in particular the difference of two squares. The basics of the difference of two squares is that we have a binomial, which we do in this problem. Next up, we have to have a subtraction between the two, and that's correct. And we at least have a chance of the variables are at least the coefficients being squares. And in this problem we got the first one, 3b squared. So this is more than likely the difference of two squares. You can see in the pattern in your notes that the difference of two squares is a squared minus b squared. Alright, so what we're going to do is we're going to substitute the a squared with our first term, which is 3b squared. Alright, that's going to represent this. And we'll do the same for the 48. Alright, now let's just see if this term is actually a square and this term is actually a square. Alright, 3. Is 3 a square, perfect square root? According to the calculator, no. But what originally thought that what this was a difference of squares was this. Let's just double check. 48. Is that a perfect square? And I checked the calculator and the answer is no. It looks like, according to the directions, if we can't factor completely, it must be prime. And most people will stop right there, but it does say factor completely. So let's go back to the first thing that we learned in our videos, GCF. Looking at my calculator, 3 and 48 are definitely divisible, and they're divisible by 3, so that's my GCF. If you remember, we take the GCF and we're going to divide out 3, so that cancels out and gives us b squared. And I divide 48 by 3 and that gives us negative 16. But remember, we're just rewriting the problem without a 3. So since we divided by 3, the opposite is multiply. And there we go. Now let's go back and check and see if these are squared. Well, originally I said b squared is a perfect square. That's true. Is 16 a perfect square? Yes, it is. In fact, the calculator says it's 4. Next thing to look at is the other part of the pattern for the difference of squares is that when you figure it out, this is what we're going to do for our final answer. We're going to put it into two sets of binomials being multiplied together. Alright, so what we're going to do here, remember this is our a, and you can see that in the final answer a is not squared. So we're going to go ahead and go b square root, and the answer was b here. So we'll put that here and here. And then you notice it said b squared in the original, and there's no square there, so we're going to square root the 16, which we found out was, of course, 4. And according to the pattern, the first one's plus, second one's minus, and that's almost our final answer. Remember that we did GCF to begin with. There it is right there. So we're going to go ahead and put it in front, and that is our final answer. Alright, let's see here. Do we have difference of squares? Well, we do have a binomial. We do have subtraction. We do have w squared, so that's a good chance that these are difference of squares because of that, the square. Let's just double check. Is 16 perfect square? Yes, it is. The answer is 4. Is 169 a perfect square? Check it with my calculator, and it says it's 13. Looks like we're ready to go. So what we do here is that we take this 16 w squared minus 169. We square root the whole thing. We know that the square root of 16 is 4, and the square root of w squared is just w. We'll square root the 169, which we found out was 13. Alright, there we go. Then we take that and we replicate it again. And notice that the signs are different. Alright, last problem, difference of two squares. We do have a binomial check. There's a good chance it's the squares because both the variables have squares, and we do have a subtraction sign. What we need to check here is 3 a perfect square root, and both of the terms have a 3. That's nope. Well, looks like we can't, but maybe we can say prime. But before we say the word prime, we should always say GCF. It looks like that they both have a 3 in common, so we can factor that out. When I divide 3m squared by 3, I get m squared. When I divide negative 3n squared, I get negative n squared. Now remember, it does say factor completely, so we got to continue on. M squared and n squared are perfect squares, as we know. So we're just going to go ahead and find the square root of m squared, which is m. Square root of n squared is n. We go ahead and put subtraction sign. That means that we're going to take the two same numbers, m and n, and because I use subtraction first, be addition there, and we are done.